Hello there, my favorite little mathematicians. This right here that you're looking at is your last notes for the year. Holy cow, I can't even believe it. So I miss you. I think that goes without saying. This has been the strangest trimester ever. We missed a lot of my favorite things together. So I'm sorry that we missed those things. I hope that you've been making the best of this really poo-poo situation. And I very, very, very much hope I get to see you again in the fall. And I expect you all, every single last stinking one of you, to come and see me, and we can talk about what might have been. Oh gosh, it's awful. Anyhow, on with math. Today we're talking about radical equations. We're going to solve these in a really fun way. I say fun, that's my level of fun, so take that as you will. Okay, key to these is to get your radical all alone. So our goal is going to be to have square root of a plus 5, especially since a is under the radical. So we want this radical to be all alone. So to make that happen, we're going to subtract 7 from each side. So we're left with the square root of a plus 5 equals 5. So the variable is under the radical. It's in the radicand. We cannot get to it because it's under this radical. We need to do the opposite to both sides of whatever the square root is. If you know, answer it in the questions now. If you don't know, here it is. Opposite of square root is to square. So we are going to square each side. When you square a square root, all you're left with is the radicand. So the square is like the eraser of the square root. Adios. And that equals 5 squared is just 5 times 5, and that's 25. So we can solve for a from here, subtract 5 from each side, and a is 20. Now we can plug this back into our equation and check to see if it's right. So we'll do 20 plus 5 plus 7 is 12, maybe. That's the square root of 25 plus 7 might be 12. That's 5 plus 7 might be 12. That's a question mark. Oh, Lord. And 12 does indeed equal 12. We did it. Let's do, let me see here. You do this one. Nah, just kidding. Let's do it together. So we've got c minus 3 minus square root of c minus 3 minus 2 equals 4. So we want to leave this radical all by its lonesome. I'm going to add 2 to each side to get it all alone. So I've got the square root of c minus 3 is 6. The radical undoer is the square. So I have to square both sides. We're left with just c minus 3 on the left, and that equals 36. To solve for c, we add 3, and c is 39. You can test that and make sure it's true. So we have 39 minus 3 square root minus 2 might be 4. Well, that's the square root of 36 minus 2 might be 4. That's 6 minus 2, and that's indeed 4. We did it! Hooray! Now it's your turn. Part 3 here. Do it. All right, so our variable is under this radical. So we're going to get rid of 4 to get the radical all alone. That leaves us with the square root of h plus 1 is 10. The square root undoer is the square. We square both sides. We have h plus 1 equals 100. Subtract 1 to get h alone, and h is 99. Let's test our theory. 4 plus the square root of 99 plus 1 is 14, maybe. That's 4 plus the square root of 100. That's 4 plus 10, which is indeed 14. Hooray! Now, this next part gets a little bit more exciting. We're going to talk about something called extraneous solutions. They are extra solutions that are not actual solutions, wow, it's confusing, of the original equations that are sometimes produced by squaring each side. That is nonsense. Let me show you what I mean by doing it. Let's look at this first part, number 4. What we looked at above was to see that our variable was under the radical, and we've got it all alone. So here we've got a radical, and it's all alone already, and there's a k here. Problem, there's also a k over here outside of the radical. Nothing we can do about it yet. So the only way we can get to this k under the radical is to square both sides. The square root undoer, square both sides. On the left, the square is the radical eraser, and I'm left with just k plus 1. On the right, k minus 1 squared is the same thing as k minus 1 times k minus 1. Not the same thing at all. FOIL method now. K times k, k squared. K times negative 1 minus k. Negative 1 times k minus k. Negative 1 and negative 1 plus 1. So that turns into k squared minus 2k plus 1. So just like we handled every other quadratic equation, we're going to get everything on the same side. So I'm going to subtract k from each side and have 1 equals k squared minus 3k plus 1. And then I'm going to subtract 1. And I've got 0 is k squared minus 3k. Because plus 1 minus 1 is 0. Now, we want to factor this, k squared minus 3k. This is an easy version because k squared and minus 3k each have a similar part of their term that we can factor out. What is that factor? I hope you said it's a k, because I can factor k out, and I'm left with k minus 3. And that all equals 0. So we learned that if two factors are multiplied together and their product is 0, that at least one of them has to be 0. So we take our two factors, k and k minus 3, and we set them equal to 0. Equals 0 equals 0. K equals 0 is one possibility. We have to add 3 to each side. To get k alone, we've got k is 3. That's another possibility. Here's where the extraneous solution comes into play. We need to now plug both of these solutions into our original equation to see if they work. Let's do that. If we plug in 0, we have the square root of 0 plus 1 equals 0 minus 1. That's the square root of 1 equals negative 1. I already know this is not an answer because a square root can never be a negative. So k equals 0 is a no. K equals 3. Try that one out. 3 plus 1 equals 3 minus 1. Well, the square root of 3 plus 1 is the square root of 4, which is 2. 3 minus 1 is 2. That one works. So k equals 3 is our only possibility. Let's do another one. Same idea here. We've got a t inside the radical and a t outside. The radical's all alone. So we're going to use that square and square both sides. On the left, we'll have t plus 5. And on the right, we'll have the product of t plus 3 times t plus 3, which is t squared. T times t is t squared plus 3t plus 3t plus 9. So t squared plus 6t plus 9. Now we got to get everything alone, or everything on one side. So sorry, subtract t. We've got 5 is t squared plus 5t plus 9. And subtract 5. We've got 0 equals t squared plus 5t plus 4. So this is a quadratic. I can't factor by grouping because there's only 3 terms. They don't have something in common where I can factor something out. So this is one of those we're going to have to make our handy dandy little table where A is 1, B is 5, and C is 4. A times C is 4, B is 5. We want the factors of 4 that add up to 5. 1 times 4, 2 times 2. 1 plus 4 is 5, 2 plus 2 is 4. This is the row we care about. So we're going to have t plus 1 times t plus 4 equals 0. If these are multiplied together and their product is 0, that means at least one of them is 0. So we do t plus 1 is 0, and t plus 4 is 0. That means t equals -1 is a possibility, and t equals -4 is a possibility. Let's plug both of those in. -1 first, square root of, not t, dang it. We just said that t is -1, so -1 plus 5 equals -1 plus 3. That's the square root of 4, which is, not square root, which is 2. And that also equals 2. So t equals -1 is true. Let's do -4. Do square root of -4 plus 5 equals -4 plus 3. That's the square root of 1, which is 1, equals -1. It does not. T equals -4 is not an answer. -1 is the only possible solution. All right, this is a lot of steps. I know. It's the end of the week. I know. But you can do it. Number 6 is all you. Bring it home. Close out this crazy trimester with a fantastic solution. Do it. Okay, we've got X's. 1 on the left, 1 on the right, and a radicand. Radicands alone, we've got a square. Square both sides. On the left, we have x minus 3 times x minus 3, which is really x squared minus 3x plus 9. That's x squared minus 6x plus 9. On the right, we just have x minus 1. So let's subtract x from each side and get x squared minus 7x plus 9 is -1. And then add 1. X squared minus 7x plus 10 is 0. Can't factor by grouping. They don't have anything in common where we can factor them out. So we got to use a table. We have A is 1. Let's fix that so we can see a little difference here. A is 1. B is -7. C is 10. A times C is 10. B is -7. Factors of 10 that add up to -7, if they multiply to get a positive and then add together to get a negative, they have to both be negative factors. So -1, -10, negative 2, negative 5. That's negative 11 and negative 7. Bottom one here is the winner. So our factors are x minus 2 and x minus 5 equals 0. Product rule tells us that these multiply together to get 0, and at least, one of them has to be 0. That means we have solutions of x equals 2 and x equals 5. We got to test those out and see which one, if any, are true. Let's do 2 first. X, crappers. 2 minus 3 equals the square root of 2 minus 1. That's negative 1 equals the square root of 1. Not an answer. Know that a square root can never be a negative. Now 5. 5 minus 3 equals the square root of 5 minus 1. That's 2 equals the square root of 4. And that is indeed the truth. So x equals 5 is the solution. I really hope this makes sense. I hope you've had a relatively enjoyable time learning algebra this trimester. I appreciate you sticking it out till the end. I know it's been rough learning from home. It has sure been rough teaching from home. I love math, and that's why I got into math education, but I didn't realize how big of a piece of my love of education was not just the math, but it was you. And you've definitely been missing from the equation this trimester. So take care of yourselves. Let me know if I can help you with this. Get all your work done. Get caught up. I love you all, each and every one of you. Holler if you need something.